this is kind of what physics is about. Position. Position means where you're at. Where am I at position-wise? I'm here. Okay, 10 minutes later, I'm here. How far away am I from where I started, right? Difference in position. So position is where you're at. Velocity is a rate. How fast did you move there? I moved 10 feet in 2 seconds, right? So that's 5 feet for every second. I moved, if you're in a car, I moved 60 miles in 1 hour. 60 miles per hour, right? So velocity is a rate, okay? It's a change in position. Acceleration is a rate of a rate, okay? So how fast were you changing velocity? How fast were you changing velocity, right? Were you speeding up or were you slowing down? How fast was your rate changing? Okay? So if you look up here on the paper, in the box there and on the board, position, velocity, and acceleration are all related. Velocity is the first derivative of position because it's a rate. It's a rate of velocity is a rate. How fast did you change position, right? If you start here, if you get in your car here, and then you end up at home, how fast did you change from here to home, right? That's a rate. 20 miles per hour, 10 miles per hour, 30 miles per hour, right? That's velocity. Acceleration is a rate of a rate. So that's why it's the second derivative. Okay? So today what they're going to do is they're going to give us something in position. They're going to give us position, or they're going to give us velocity, or they're going to give us acceleration, and they want us to find certain things about it. Okay? So it kind of seems like this is kind of weird. We've never talked about position, velocity, or acceleration, but they're all related by derivatives. So that's why it's in this chapter. Okay? So the first page, that first page that you guys have in front of you, it's all a bunch of, it's kind of your cheat sheet. Kind of your cheat sheet. Remember last section, we made a cheat sheet so we know where to look. So for this, right, we made a cheat sheet, right, to know where to look on the graphs. Well, this is that version of it because they're going to ask you these questions. They're going to ask you, what was the average rate of change? What was the instantaneous rate of change? Right? What was displacement? When was a particle at rest? When did a particle change direction? When was velocity accelerating? And then they're going to bring up this thing called speed. Speed. Speed and velocity are the same thing if they're positive. If they're not positive, so when you're in your car and you look at your speedometer and it says 40 miles an hour, that's what we call speed, right? That's your speed. Speed is the absolute value of velocity. In other words, speed is always positive, right? If you look down at your speedometer, it never says negative, right? It never says negative 20 miles an hour. It never says negative 10 miles an hour. It's always positive, right? So velocity and speed are the same thing if velocity is positive. If velocity is negative, then you have to change it to positive to make speed. So they're the same thing, but velocity has absolute values. Okay, so that's how speed and velocity are related. Okay, so if they ask us about speed, we're going to find velocity. Whatever velocity is, if it's positive, leave it. If it's negative, change it to positive. Okay, so that's how they're related. Let's see here. What else? When is speed increasing? Speed is increasing when acceleration and velocity have the same sign. Speed is decreasing when acceleration and velocity have opposite signs, because they're going to ask us questions. Is the speed increasing? Is the speed decreasing? This is where we're going to go. Okay? Okay, and then here's the table. The table kind of gives that same thing. They're going to ask us, when is the object slowing down? Well, slowing down means velocity is positive, acceleration is negative. or acceleration is positive, velocity is negative. So it's going to help us answer questions that we're going to see here in a little bit. Okay? That's what the table is for. When velocity equals 0, it means you're not moving, right? Velocity equals 0, it means you're not going anywhere. The rate of change is 0, right? If acceleration is 0, that means you're just kind of moving in the same speed, the same velocity. You're not changing, you're not speeding up, you're not slowing down, right? It's kind of like on the highway. If you just set it on cruise control on the highway, you're just going the same speed the whole way. That's when acceleration is 0. The rate of change is not changing. Okay? And then they're going to ask you questions. They might say, when does the object move left and right? What does that mean? Well, it has to do with velocity. Velocity is negative, object moves left. Left is the negative direction. That's why it's less than 0. When is an object stopped? When you're not moving, velocity is 0. When is an object moving right? In the positive direction, when velocity is positive. Okay? So this sheet, this front sheet, that's why I put it first, because we're going to come back to it a lot, because they're going to ask us different questions, and the answers will be on this sheet. Okay, so this is kind of like our cheat sheet. All right, okay, so let's go to the back. Let's go to the next page and see what question they ask us. Okay, example number 1. A particle moves along the x-axis, so it's moving left and right. If it's moving along the x-axis, it's only moving left and right. Okay? So that at time, so it starts at 0, time can only be positive. So time is greater than or equal to 0 means it starts at 0 and time is only positive. We can only move one way in time, right? We can't move back in time. Okay? Its position is given by this guy here. All right? Its position is given by the equation. Okay? The equation x of t. So position, they'll either call x of t or they'll call it s of t. Some books call it x of t and some books call it s of t. That's why I put both. That's the equation for position. Okay. Determine the acceleration of the particle when time equals 7. Okay. So they've given us position. What's the relationship between position and acceleration? Second derivative, right? So to answer this question, first thing we're going to have to do is find the second derivative. Okay, so x of t is t to the third minus 11t squared minus 16t, right? That's position. The relationship between position and acceleration is second derivative. So I need to find the second derivative. Okay, so the first derivative is going to be 3t squared minus 22t minus 16. Second derivative, 6t minus 22. So acceleration is the second derivative of position, the first derivative of velocity, or sometimes we just call a of t. Okay, so if you see a of t, it means the same thing. Okay, so now that we have that, determine the acceleration of the particle at 7. So what do you think we're going to do now? Plug in 7. (42 minus 22 equals 20). Acceleration is 20. They don't give us units, so we don't have to worry about units. If they give you units, then you have to do units. Okay? But they didn't give us any units, so we're not going to worry about it. Okay? All right, let's look at example number 2. A particle moves along the x-axis, so it's moving left and right. Right means positive, left means negative. Time starts at 0. Its position is given by x of t. Determine all values when the particle is at rest. So when is the particle at rest? When what is 0? You're right. Something about 0. When what? Something is 0. When what is 0? Not t. Not it. You're close. Getting closer. Velocity is at 0. Yeah. First page. Yep. I saw some of you go into that first page. Good. That's what it's there for, right? Object is stopped, right? Object is stopped. Where is it? It's also right here. Particle is at rest when velocity equals 0. All the answers are there. You just got to kind of look it up, okay? That's what it's there for. That's why I put it in the front, because a lot of your answers will be answered by just looking at that first page. So if you're not sure, go to that first page, okay? So this means when velocity equals 0. Do we have velocity right now? No. So what do we got to do to find velocity? Take the first derivative. Good. First derivative. Okay. There's the first derivative. What do we do now? Set it equal to 0. It's a trinomial. So GCF, I think we can divide them all by 3. Factor it. So we got to come up with the two numbers that multiply to be negative 12 and add up to be 4. Positive 6 and negative 2. Set all of those terms equal to 0. Since they're all factored, set them all equal to 0. So 0 equals, 3 equals 0. T plus 6 equals 0. T minus 2 equals 0. So the first one, 3 equals 0, that's not true. Doesn't have a t to solve for, so I can't get an answer from that guy. Okay? So I get two answers, because it wants all the values, right? All values of t when the particle is at rest. So negative 6, t equals negative 6, and t equals 2. I put that answer in, and it says wrong. Why?
Negative 6 is like under 0.
Yeah, time can't be negative. Time cannot be negative. Time has to be positive. It says so right there. And we just know time can't be negative, right? We can't stop time. I can't go back in time, right? Time just keeps moving. So negative 6 I can't use. You get positive 2. Okay? So at positive 2, the particle is not moving at all. Velocity is 0. Okay? All right, let's look at the next one. Okay, so a particle moves along the x-axis so that at time starts at 0, time's only positive. Its position is given by, so they've given us position again. Determine if the particle is moving to the left or to the right. Oops. At that time. What the heck does that mean, left or right? Positive or negative, what exactly is going to be positive or negative?
The speed.
Velocity. Velocity will be positive or negative. The very bottom, that box at the very bottom. Moves to the right means velocity has to be positive. Moves to the left, velocity has to be negative. Okay, so that's what we have to check for. So they want us to check. So velocity, move to the right means velocity is positive. Move to the left means velocity is negative. We have to see which one is it doing at positive 5. So in other words, what are we trying to do? Let's use I'm not worried. Let's not worry about position, velocity, acceleration. But what are we trying to do here? We're trying to find what? I know we're trying to find if velocity is positive or negative, but what does that mean in terms of what we have to do? First derivative, and then what do we have to do with the first derivative? Not set it equal to 0.
Plug in a number in the place.
Plug in 5, and then do what? Once we get an answer,
Plug in a number.
see if it's bigger than or smaller than 0. Yeah, they want you to see if the derivative at 5 is positive or negative. That's what all they want you to see. See if velocity, sometimes they'll give you velocity. Sometimes they'll say v of t equals that. Then you don't even have to find derivative. You just plug it in, right? But since we don't know velocity, we got to do that first. Negative 2t minus 8. That's velocity. Plug in 5. Negative 18. Particle is moving left at t equals 5 because v of 5 is less than 0. I plugged in 5 to the velocity and it was negative. So that means it's moving to the left. At time 5, it's moving to the left. All right. So this is only, since this particle moves only along the x-axis, it's only going left or right, or stopping. It can't go in any other direction. Okay. So the hard part about this is just kind of translating what the heck does that mean? What does it mean moving to the right and moving to the left? All stuff you've done before. How many times in this class have you found the derivative and plugged a number in? Too many times to count, right? You guys have done that many times. So it's not anything you haven't done. This section isn't anything you haven't done. They just give it to you as in a form of position, velocity, and acceleration. Okay? So the hard part is translating what in the world are they asking me to do. And that's what that first page is for. Okay? That's what that first page is there for. Okay? Okay, so a particle moves along the x-axis. Time is positive. Its position, again, they've given us position. Determine all intervals, so this is what they want. Determine all intervals when the speed of the particle is increasing. What does that mean? Let's interpret, let's translate. What the heck does that mean? That's a science term. What does it mean in terms of calculus? We're gonna have to find the first, but what do we have to, how are we gonna know if speed's increasing or decreasing? Not just the velocity. Speeding up, right? Speed's increasing means speeding up. Also, here. Speed is increasing when acceleration and velocity have the same sign. So if acceleration and velocity have the same sign, speed is increasing. So we need acceleration and velocity. Okay? So I need both. So let me find velocity first. 4t to the third minus 36t squared. Acceleration. 12t squared minus 72t. So this is velocity. This is acceleration. Got those two guys. What did it say when those two guys are what? The same sign. What does that mean to do with each of these guys? I'll give you a hint. You've done it before. Not second equal to each other. We're going to treat them separately. We've done this before. Let me show you where we've done it. First derivative test was for the first. Doesn't this tell you where the first derivative is positive and negative? That'll tell us for velocity, right? That'll help us for velocity. So that's how we're going to find where velocity is positive and negative. How are we going to find where acceleration is positive and negative? Second derivative test. Right? Second derivative test. Second derivative test will tell us where acceleration is positive and negative. And then we're going to overlap them and see where they're the same sign. Okay? Kind of like when we did this question here. Where is it both decreasing and concave up? Where is it both decreasing and concave down? Essentially, we're doing the same thing. But instead of using decreasing and concave down, we're using velocity and acceleration. So it's doing the same thing you've done before. So first derivative test. On the first derivative, set it equal to 0. It's a binomial. GCF. 4t squared. And 9. Set 4t squared equal to 0. Set t minus 9 equal to 0. I get two answers. Zero and 9. 0 and 9. Here's my question. Am I going to use both of the answers? Are both answers, can I use both answers or can I throw one away? So 0 actually is in the interval because its t is greater than or equal to 0. But is there going to be anything less than 0? So I don't have to check anything less than 0, but I can use 0. First derivative test, 0, 9. So again, I don't have to check anything less than 0 because time can't be negative. Time cannot be negative. So all I have to do is check in between and bigger than 9. So how do I check? I plug it into the first derivative. Plug in numbers into the first derivative. 1, 10, 4, 1 cubed minus 36, 1 squared. I get 4 minus 36, which is negative 32. So that means I'm going to have a negative decreasing. Four, 10 cubed minus 36, 10 squared. Let's see, 10 to the third power is 4,000. Or sorry, 1,000 times 4 is 4,000. 10 squared is 100 times 36 is 3,600. So we get positive 400. I'm going a little fast here because we've done this many times before. It's essentially the same thing we did last week or the week before. So that's the first derivative test. Second derivative test now. Set it equal to 0. GCF, I believe that's 6. T equals 0. T equals 6. Again, can't have a time less than 0. So when I draw my number line, it's going to start at 0. And we'll have 6 on there. Same thing. Plug in a number in between 0 and 6. Plug in a number bigger than 6. See where the second derivative, acceleration, is going to be positive and where is it going to be negative. So plug in 1. If I plug in 1 to the second derivative, I get negative 60. Plug in 7. You know what? I'm just going to use 10 again because 10's a nice round number. You can use 7, but I like to use, especially because this test probably won't be calculator. Well, no, you can't use a calculator on this test. So pick round numbers where it's easy to multiply, right? 49 times 12 isn't as easy as 100 times 12. So you get 1,200 and 720, which is positive 480. Okay, first derivative test done. Second derivative test done. Now we're looking to see where they have the same sign. Where are they both negative? Where are they both positive? Okay. I know you can't do this on yours, but this is essentially what we're doing. Overlapping them. Where is the sign both positive or both negative? Wait. Why did I use different colors there? Let me change the signs real quick. So let's see. So it looks like from 0 to 6, they're both negative. So 0 to 6. And then from 9 on, they're both positive. The only place where they have different signs is in between 6 and 9. Okay. So we're going to write speed is increasing from 0 to 6 and 9 to positive infinity because velocity and acceleration have the same sign. Acceleration and velocity have the same sign. So swap out where is speed increasing for where is it concave up and increasing. Where is it decreasing and concave down? You guys have done that before. That's essentially the same thing we're doing. Okay. All right. So like I said, today, this lesson is about just translating. What the heck are they asking for? That's where you use that first page. Use that first page because the answers will always be there. Okay, so let's start on the graphs now. So one part is the equations. They give you the equations. Here's the equation of position, velocity, acceleration. Now they give you graphs, and they're going to ask you the same questions. Okay, so I know it's not green on yours. So the green dots, mark them on yours. I know they're not green on yours, but they're supposed to be inflection points. Okay. So they've given us inflection points. So inflection points, what do they represent? I know they're second derivative things, but why are inflection points? What do they tell us? A change in what? Okay, a change in sign. That'll help us do what? What do they tell us? A change in sign and a change in, starts with a C. Concave up, concave down, right? So before the green dot, concave up or concave down, and then after the green dot, it changes, okay? It changes. Now these are inflection points, not for the graph. They're inflection points for the original, okay? Okay, so the particle moves along the x-axis so that the velocity goes from 0 to 18. Okay. Whose graph is shown in the v of t? So this graph is a graph of which one of these? Velocity. Velocity. Tell me about velocity. Velocity is a derivative. So this is a graph of the first derivative. Does that sound familiar? Very familiar, right? We just did that, right? That's why we do that lesson first. So when we see this, you notice it, right? So it's a graph of velocity. So velocity, let me write this down. Right? And velocity is the first derivative of acceleration, right? That's what we're looking at. The derivatives of position. The slopes of position. Okay. Inflection points are in green. Find all the intervals of time when the speed is decreasing. Speed is decreasing. So tell me about speed is decreasing. When do we know speed is decreasing? concave down. So let's use terms that we see on here. Use that in terms of position, velocity, acceleration. What is position? What are these guys going to be? Good. Go to that first page. First page has all the answers. When is speed increasing or decreasing? Sorry. When is speed decreasing? Have what? Opposite signs. So velocity and acceleration have opposite signs. That's what we're looking for. We're looking for velocity and acceleration to have different signs. Okay. So let's start with velocity. How do I know where velocity is positive and negative by looking at this graph? How do I know where velocity is positive or negative by looking at this graph here? So where do I look at the graph? I want to know about velocity. I want to know where velocity is positive or negative. The y values. Isn't this a graph of velocity? So when y is positive, velocity is positive. So let's go find out where velocity is positive. I'm going to highlight it in yellow. There, right? Positive y values. And there, right? Velocity is greater than 0. Okay. Where is velocity going to be negative? The opposite, right? Where the sign below the x-axis. Okay. So I know where velocity is positive. I know where velocity is negative. How am I going to tell when? Oops, missed a spot. There we go. How am I going to know when acceleration is positive or negative? How am I going to know when acceleration is positive or negative? Looking at the slopes of this graph. Looking at the derivative of this graph. Derivative means slopes, increasing, decreasing, right? So where is this graph increasing and where is it decreasing? I don't want to use a colored marker because it but essentially it's decreasing. I'll just use red pen. Right? Before that red, it's decreasing. Between the red, increasing, and then decreasing again, right? So let me section it off. So this is where acceleration is negative because it's decreasing. This is where acceleration is positive because it's increasing. And this is where acceleration is negative because it's decreasing. Now I have all the information I need. Now I need to know where do they have the same sign. Okay, so yellow means positive velocity. So positive velocity So different signs, right? I'm looking for different signs. So here is positive velocity, right? Is that in an area where acceleration is negative? Yes, then I definitely want that part. I definitely want that piece. So let's write that down. 0 to 1. Okay. And then velocity is negative. So is acceleration. I don't want that. I don't want same sign. Okay, let's go to this one. In this little corridor here, in this little section here, between the red, that's where acceleration is positive, right? So in between there, I'm looking for where is it negative? Where is velocity negative? Right there. This little corridor here, or this little guy here. All right? That's from 8 to 11. 8 to 11. Okay, let me do the last little section here. So this is where acceleration is negative. Where is velocity positive? 13 to 16. Yep. So I'm going to say speed is decreasing from 0 to 1, 8 to 11, 13 to 16, because V of t and A of t have opposite signs. Okay. We'll stop there for today. Speed is decreasing in those three areas because velocity and acceleration have different signs. Okay? All right. Okay. So we'll continue. We'll finish tomorrow. We'll finish this tomorrow.